Hello and welcome to TidyX episode 122. TidyX is a screencast where we explain how our code works. My name is Ellis Hughes.
And my name's Patrick Ward, and we are at episode 122.
Hey, made
Here we
it.
go.
Yeah. So this week we're going to be looking at doing some filtering and looking at types of data where events are occurring. So
Yeah.
I think this is something that if you do data analysis like ever, you're probably going to come across some of events-based data. And so we wanted to give you a couple ideas of techniques that you could use to start observing and working through your data. Patrick, do you have anything else to share as I make it so
Yeah.
everyone can see the code?
This is probably what I would file under the advanced filtering type of techniques because they can be a little tricky, and you'll have to bear with us as we sort of describe some of these things because we're sort of like making up research environments to the simulated data that we're going to build. But anybody who works with time series data, such as survival analysis, and you want to right center everybody, maybe where the right center people where the event occurred first, and then wash them from the database. You might use types of filtering like this if you're dealing with like player tracking data, like the big data bowl just came out, and you want to filter between types of events, like show me everything that occurred on a play between ball snap and pass forward, or between pass forward and tackle, or something like that. This would be time series type filtering. They can get a little bit confusing because you're trying to think through when does an event occur, how many row numbers have happened, and things like that. So we're going to try and walk through some of these so that you kind of have the tools in place to do these for your own research environment and research question, because the research question is really going to drive the way in which you apply some of these types of techniques, and ask ask R to report the data back to you.
Exactly. So without further ado, let's get started. So of course, we are going to be loading Tidyverse. This is the only package we need this episode. And that's going to provide us, all our data manipulation needs. We are not dealing with actual like date data, so we're not going to use like LubriDate or something like that. We might do that in the future. Let us know in the comments down below if that's something you want us to do. We're going to simulate some data real quick for us, so you can reproduce it. We are going to set a seed, this time being 35, and then we're going to construct our data set that we're going to use. Because clearly this is very simulated data. This tibble is going to have three different columns. This first one is going to be a participant, which is the unique identifier for the individual. In this situation, we're going to have three individuals. All right, and the way that we're constructing this is we're grabbing from the letters vector, which is a capitalized alphabet that's just like included in base R. We're going to grab those two, and we're going to repeat each of those 20 times. And so what this is saying is we're going to have 20 records for A and 20 records for B. And then here we're going to say grab the third letter from letters, which is C, of course, and we're going to repeat that 8 times. So we're only going to have 8 observations for C. And then we're going to concatenate it together using the C function. Then we're going to have observation number. And so this is just, number of times those participants are recorded here. And so these two are going to reflect each other essentially. So 8 and 8 and 1 through 20 and 1 through 8. And we're going to repeat 1 through 20 twice because we have A and B 20 times a piece. And we're going to have 1 through 8 listed once. And then finally, the thing that we actually not actually care about, but the purpose of today's episode is event. And we're going to have this randomly generated, which is why we wanted to set a seed. This is going to be a value of either 0 or 1. We're going to have it occur 48 different times across our full data set. You might want to do this by participant if you were to do a little bit more simulation. We're saying replace is true, so you can grab a 0 or 1 multiple times, which makes sense because we only have 2 entries and 48. We want 48. And we're saying the probability of an event is 75% chance of it being a 0 and a 25% chance of being a 1. And so there's going to be more zeros in our data set than ones. I think by default it tries to split it evenly. In this situation, we're trying to make 1 a rarer event. So now we've got our data set here. I guess I kind of skipped over. Obs number is observation number, and then event, which is that binary, is a binary indicating whether event occurred or not during said observation. And so we have, participant A had an event at 1, at 4, and at 9, and at 10. Oh, I didn't set a seed.
I think you did.
I
Yeah.
did? Okay.
Yeah. Hmm.
All right, so let's get some simple, like high level information about our data set here. How many events did each participant have? And there's two different ways that you can do this. The first one is to, all right, just filter, give me event, and then count the number of times participant occurs. Or no, count, yeah,
The number of participants. Every time you see participant with event one, yeah.
yeah. And then this is going to give us for participant B, they had 7 observations. For A, they had 6 observations. And for C, they had 4 observations. Another way you could do this is rather than filtering on event, you could just group by your participant. And since we know event is binary, 1 or 0, we can sum event. And that'll tell us also the number of events a participant or number of events a participant had. And so here we get the same values, just slightly different way. But what if we wanted to have a running count, Patrick?
Yeah, so running count is pretty easy because the event is binary zeros and ones. This cumulative sum function, cum sum, can be used, and all we have to do is pass it event equals one. So basically, this is a conditional function. It's basically saying anytime event equals one, add an additional digit. So here we go. We start at one event group, and event one happened for participant A in the first observation. And so that individual gets a one, and that one carries on until row 4, where it says, oh, hey, look at that. There's another event that occurred. Let's add one. And now it goes on. It's all organized as event. Everything here is event 2 until we get to row 9 and then row 10. And if we were to filter to any of the participants, we would see the same type of thing. It's just literally doing what the function is doing, cumulative sum, as it parses down the rows, checking every time for event equals one.
Okay.
All right. Now, this one's trickier. So this one is we're looking into the data, and we're creating that same cum sum event equals one. So that's going to be that running tally that's going on there. But now we want to say, what if there was a time where we want to find the event, but then we also want to know what happens in the 2 observations after that event? So let's use like an example where maybe like a social worker is trying to evaluate what happens in the 2 observations following an epileptic seizure for participants in a study. So the way that we would do that is we're going to keep the same 3 rows of script initially the same. So 39 to 41 is what we've already done, adding that cumulative running total. Then we're going to add this additional group by, which is we're going to group by the event group. And I use the .add equals true function here. And what this is telling us is we haven't done this before, but this is telling us, hey, we want to keep the previous groupings that we have. So we want to keep that previous participant group by. We don't want to override that, but we want to add event group to this. This would be the same as if we actually just did participant group by participant comma group event group. We could get rid of the add true, and that would be the same thing. Either way, they're going to accomplish the same thing. I just decided to show this in case anybody wanted to see an alternative route.
Mm-hmm.
So once we've got our data now grouped by participant and event group, we're going to use filter. I'm going to say, hey, filter, when we're looking at these event groups, take the row number that is 2 or less of the event. So remember, we're looking at when we see this event and also the subsequent 2 rows if there are 2 more rows after that. So if we run this, we're going to use the print function to print the entire data set back to us so we could see everybody. So let's go up to participant A. Remember, they had an event in row 1. And so we see row 1 and row 2. And then they had an event in row 4. And so we see the next 2, 4, 5. And then they didn't have an event until row 9. And then they had an event again in row 10. So nothing obviously gets returned between those. They just get returned as is. And so this is a way to find an event and then find any of the
Subsequent.
observations after that event. Right.
The number of subsequent observations after this event. And so this,
Correct.
we
Correct.
said too, technically, because of the way that's structured, that is just like the actual event and that, and then the one after that. If we wanted the two, we'd have to up our number to three.
Bump it up. Yeah, exactly.
And so
Exactly.
it's however many observations you're interested in looking at is what you can
Yeah.
use to do
The
that.
research question will dictate that. You probably have prior knowledge from previous research saying, like, oh, we always look 5 seconds into the future or 20 seconds into the future or whatever that might be. That's how you'd handle that.
Yeah, exactly. But now let's do some filtering here to identify what filter every subject's time from start to their first observation. So how long until their first observation in the data set. So sometimes there's information you want to gather from before your event started, and then after that, this is kind of more often I see this like survival analysis when you're trying to identify when a participant had an event, and then you can do some Kaplan-Meier plots and whatnot, which we're not going to do in this episode. Once again, let us know if you want us to do some Kaplan-Meier plots to demonstrate when participants kind of fall out of quote unquote or have then had an event, so you can
Yeah.
look at differences in treatment and whatnot. And
Yeah.
so here, all these participants had very early events. They all participant A and participant C had an event at observation 1, but participant B had their first event in observation 2. And so that is a way that you could look at. So sometimes I think when we were doing a prior simulation, participant A didn't have any events until observation 10. And so maybe we would want to lop all those off or keep them and observe everything up until that point. So there's a couple different ways you might want to look at
Yeah.
it. So next we want to look at duration between events. So this is how much time has elapsed from event 1 till event 2. And this will be recorded at event 1. Okay, you've had one event. How long until the next one? So we're going to, again, group by participant, mutate event number, cum sum. If you notice, there's a pattern. We're doing a lot of cumulative sums of events.
Yeah.
We're going to also then group by event number and do .add as true. But instead of doing a filter or whatnot, we actually are going to do a summarize. So summarize, when you add this to groups, removes all extra information. So we're only going to be keeping participant and event number. And then we are going to do duration equals n. So this is saying how many rows exist between or in each event number, because that would tell us the number of events that occurred before the next event. And then we're going to filter any cases where event number is not 0, because we do not want anything before they had an event, because that doesn't add any real information, because we don't know, like from the time we started observing, there could have been some variables included there. So we can run all that, and we can see that participant A, event number 1, it was then 3 more observations until they had another event. And then after that, it was 5 more observations until they had event number 3. And then only 1 until they had event number 4. And so you could maybe look to see if there's an increasing or decreasing amount of time between event numbers across your participants and whatnot. Then finally, this one took us a little bit to kind of like think about and figure out. But I think this is a very interesting way to approach this. Patrick, do you want to take us through this?
Yeah, this is this is used whenever you need to grab observations that occur between discrete events. So just like at the beginning of the show, I gave the example of the NFL Big Data Bowl. This would be in like any sports tracking data where you're trying to filter data between events. So again, ball snap to pass outcome, or maybe if it's basketball, it's like everything from first pass to shot. So what are the events that, or what are the activities or the movements that occur between those events? So we kind of take our original data frame and we just add to it so that we can have these discrete events. So we used more of like a kind of like, let's say, clinical type of event cases here, where maybe we're tracking humans wearing activity watches, and we want to know, like, let's say Ellis and I are trying to build a model that identifies from people's like Garmin watch or their Apple watch the type of movements that they're making. We want to build that model and we want to know when these events occur, because the activity on that accelerometer is going to have different spikes and different types of patterns that might be unique to these events. So we added to our data set, we create a mutate here. Again, the event number, the cum sum event. As Ellis said, there's a pattern there. There's probably ways to do this without cum sum. I just always do it because in my head, it helps me to have that sort of running tally on the side because I know where I'm at. And especially if you're dealing with thousands of rows, it's like, okay, where the hell am I?
Yeah. Yep.
So it's easier. The observation type here. So anytime the event number is 1, so anytime we see an event and it's the first event, we're just going to call that stand. Anytime we see an event that's the second event for the individual, we're going to call that start activity. Anytime an event happens and it's the third event for the individual, we call end activity. And then the fourth event for the individual is lie down. Not every individual is going to have these 4 activities, but we're sort of pretending that we've got activity watches on people and we're watching them in the wild for a certain period of time to see what happens.
Yeah.
So now we have a data set, and you'll see between these events is a whole bunch of NAs. So if we were to just run everything to line 74, there we go. Yeah, perfect. So we see stand, NANA, start, NANA, end, and then they lie down. And that's
They're very fast. They're like, I'm done, going to sleep.
Done. Yeah, it's over, right? So, okay, cool. So we've got an observation type that we want to do something with. So let's say we want to filter between the start activity and the lie down activity. So basically, we don't care about standing here. We just want to see, what did activity look like? What accelerometer data did we have going on between the start of their activity and the lie down activity? So we do this filter between. So this is one that I use a lot. So filter, and then inside of our filter function, we're using the between function, which is basically a function that says, hey, grab everything between what I specify on the left and what I specify on the right. So here I'm saying grab all of the row numbers between on the left anytime the observation type equals start activity. So I use which here, and that's just sort of like a conditional statement that's saying, hey, identify that row wherever it says observation type equals start activity.
Yeah.
Okay.
And this is also assuming there's only one start activity.
Yeah, because if there are multiple, we'd have to solve this a different way, and maybe we can do that in a future episode, which would be
Let us know down below.
Yeah, because otherwise you'll get an error barked at you.
Yeah. See, this is which returns an integer of the position of trues in your vector.
Correct. Yep, that's right. On the right side of the between, we did something a little funky here. So instead of repeating what we did above and saying which observation type equals lie down, if we did that, R is going to bark an error at us, because some of the subjects, some of the participants within this study, they don't have a lie down. They haven't lied down. They went through the study and didn't lie down. So R says, I don't know what you want me to do here. I can't find this event for some of these participants. So it'll say error participant C, no event found, right event not found, not identified. So we use min and we wrap that around which. Okay, so what is min going to do? Min is also going to check a condition. So similar to like an if else here. And min is saying, grab the minimum value from whenever you see the observation type lie down, or n. And n is saying, these are all the row numbers. Remember, we're grouped by participant. So n is saying, okay, what's the minimum value? If which returns a false, then the minimum value is effectively all of the observations for the individual within this study. If which returns a true, n is effectively nullified, and the minimum value that's seen within this is going to be the observation lie down. So now if we do this filter between, we have a cool data set that we've been able to filter out between observations within time series data. So we're filtering. So if you think like maybe we have extra columns that are like GPS coordinates and accelerometer data and all that kind of stuff, gyroscope data and all that kind of stuff. This is a really cool way of using a column that has observation types and say, gosh, I'd really love to grab all of the information only between these observations.
Mm, exactly. So it'll keep it from erroring out. So building into your code a lot of like kind of fail safes for I know or I think this is how it should be, but I'm not. It's not maybe not always going to be the case, or there may be data that you haven't seen yet, but you want to just be able to throw it in your pipeline. Having these fail safes that are going to make sure that you don't error out, but will give you reasonable values out is really important when you're coding up these things. When you're coding up like one-off scripts, it's a lot easier to just kind of do it and base it on the data that you've got. So in this situation, when we resimulated this, we did have lie down for all of our participants here. But if for some reason in the future we may not, this protects us. And this is then going to go, well, we then, if they've never lied down, maybe we stopped recording before they lied down. And so we know that we want everything up until then. And
Mm-hmm.
that's fine.
Yeah.
And the same sort of idea could be used for start activity, where rather than you could also do a minimum as well. And if they, for some reason, they didn't have a start activity, but then well, it's likely that when we just started recording, that's what we want. So you could do, a maximum. You do maximum of 0, meaning the first or 1 being the first observation, and or when start activity,
Yeah.
and that'll protect you.
It would only be zero in Python. It's a bad joke.
Yeah. But yeah, so that is how you can use some tidyverse tools to work a little bit with observational time series event data. Let us know down in the comments if there's something that you've seen that you would like us to look at or explain because it confused you, or if you've got some data that you would like us to go through. Like, once again, give us a specific question that you have, and we're happy to help out with and give you and our viewers some ideas on how they could approach getting from point A to point B
Yeah.
using R and Tidyverse and whatever other things we have in our bag of tricks.
Yeah. Totally. Cool.
Yeah. So with that, Patrick, unless you have something else you'd like to close out with,
That's it.
thank you all for joining us so much. As always, my name is Els Hughes. You can find me on Twitter at @else_Hughes.
And my name is Patrick Ward, and I am on Twitter at OSPPatrick. And you can find the both of us on Twitter at tidy_explained. Tidy.explained@gmail.com is where you can email us, but most people seem to enjoy going to the YouTube channel, liking and subscribing, dropping the comment question down below. We appreciate that. And if you feel like what we're doing has impacted you in a positive way and you'd like to support our work, we do have a Patreon page, and we're always grateful for anything that you'd be willing to share.
Yep. Thank you all so much, and keep on exploring your world.